Okay, so here is the first tutorial worked example that I'm going to do, and I'm going to do question 3. So let's go in and let's have a quick read. So first of all, the key thing you're going to do at this point with doing discrete random variables is we want to be able to recognize which distribution we're going to use. So let's look for information contained to give us some ideas. So let's start by having a quick read. We have an oil company drills a succession of holes in a given area to find a productive well. The probability of finding a productive well on a given trial is 0.2. So first of all, we have some interesting information. We've mentioned a trial and we've got a probability of 0.2. So there's a Bernoulli. But let's see what it says next. What is the probability that the third hole drilled is the first to yield a productive well? Well, that's a very complicated way of saying they keep trying to do it until the first time they get a success. So what we've got here, so the first to yield a productive well, you should be thinking geometric. Okay, so now at that point, the first thing I would always do is write down the information we have been given. So what information have we been given? We'll go let y be the random variable that is the number of trials until the first productive yield. And what do we know? We know that y has a distribution that's geometric, 0.2. In question A, we want to know the probability that y equals 3. Well, now we know what sort of distribution we have. The next thing we should be doing is going to our slides and getting information. So here is the probability mass function. So as we've seen before, this is the number of failures, and then we got a success. That's all good to go. So if we go back to our question, we can substitute that in. So what do we want? We want 0.8. We have 2 failures, and then on the third one we have a success. If you do that calculation, you should get 0.128. Let's check that. How can I check that in R? That would be d geom x equals 2, prob equals 0.2. Why is it 2? Because with R, it counts the number of failures. So let's go to R. Let's come here and let's check it, d geom. So we've got x equals 2, prob equals 0.2, 0.128. Excellent, it agrees. So now let's look at the next bit. What have we now got? If the oil company can afford to drill at most 10 wells, what's the probability that the company will fail to find a productive well? So this is still a geometric. What it's saying is that we're counting till the first success, and we don't know when that success happens, but it doesn't happen in the first 10. Okay, so let's think about what we've got with our calculation. So B, let's get a new sheet. B, we want the probability that y is greater than 10. That is, we don't know when the success is, but it wasn't in the first 10 trials. Well, as always with these, we try and convert it to a CDF. So that is going to be 1 minus the probability that y is less than or equal to 10. Let's convert that into an R statement. That's 1 minus, I've got now less than or equal, so I've got the CDF. So that is going to be P geom. We're going to do 9 because I want the failures, and probability equals 0.2. And so let's go to R. We've got 1 minus P dum. This time it's Q is 9. Probability is 0.2. So we've got 0.1074 because I've rounded that to 4 decimal places. So now let's look at the final bit. How many wells would it be expected to drill until they find productive well? So now expected drill basically says we want the expected value. So let's go and check what that is. Okay, so we know that the expected value is basically that. It's 1 over P. So we can go back to our calculations and say C, we'll write what we want. We want the expected value of Y. And that is going to be 1 over P, which is 1 over 0.2, which is 5. Okay. So how do we do this? Well, first of all, we read the spiel. We tried to identify the distribution. We looked for some key signs. In this, we kept going until we had a success. So that automatically made us think of a geometric. We knew it was discrete because we were counting the number of trials. Then we went and got the slides and found all the formulae that we needed. And from there, we could then shove the calculations in. The other thing to remember is at all points, you're seeing lots of work and I'm justifying this calculation. Okay, see you next time.